Hello, we are done with motion in one dimension. Okay, so just a quick, very quick revision. When do we say that an object is moving in one dimension? We say so when the object it does not change direction while moving. For example, this guy here, he's going in one direction only. The skier, he's going in one direction. He doesn't go left or right. The rocket over here, it's going upward. It's not going left or right, okay? So in these cases, we say the motion is in one dimension. And if the acceleration is constant, we can use these equations. So this is revision for chapter 2. Now, what really happens in real life? In real life, there is almost nothing that moves only in one dimension. Many objects like the water over here, the dolphin over here, the ball, it's actually moving in multiple dimensions, but let's just say that it's moving in 2 dimensions, okay? So it's not simply up and down or left and right. It's a combination of both. And that's when we say that the motion is in 2 dimensions. I don't know if you remember this game, Angry Birds. You had to pull the object over here, and then depending on the angle you pull it and the strength of the force you pull it with, you can reach your target over here. So depending on the initial magnitude of the velocity and the angle, we can change the path of the bird so it would hit the green target. Okay. This also happens when a basketball player wants to get a basket, shoot his ball into the basket. He has to do it with an initial velocity and an angle that will allow the ball to go from the initial position to the final position. If we look now at the initial position, we can just say it's 0. Now we have to say it's 0, 0, and it hits the basket at position, for example, 4.11. Okay, so now we're not saying it's going from position 0 to position 2. No, it's going from 0, 0 to 4.11, and that's when we say both x and y are changing. Not only the x is changing or the y is changing, both of them are changing, and this is again motion in 2 dimensions. Before I continue talking about motion in 1 dimension, I want to make some mathematical background to remind you of some trigonometry. You might have seen this, you might not have seen this, so we will go through it together. Consider any right triangle CAB right at A. Okay, consider a triangle CAB right at A. We use this. Now, let's say that angle C is theta and angle B is alpha. Okay. Now, what do we know? We know Pythagoras theorem. Perhaps you remember it or not. Pythagoras theorem say that the hypotenuse square, this is the hypotenuse, it is the side facing the 90 degree. The hypotenuse square equals side 1 square plus side 2 square. This is Pythagoras theorem. So in this particular triangle ABC, we have BC square, which is the hypotenuse, BC square, it's AB square plus AC square. Okay, this is Pythagoras theorem. Now, trigonometry, sine of an angle, we call this sine of an angle, it's equal to, let's first clear, sine of any triangle, let's say angle theta. Sine of any triangle, it's equal to opposite side divided by the hypotenuse. This is the hypotenuse, remember? Let's do it like this. This is, sorry, divided by the hypotenuse. Just look at this. This is the hypotenuse. So sine of any angle, sine of theta, for example, is equal to the opposite side divided by the hypotenuse. The opposite side is AB. So sine theta is AB over the hypotenuse, which is BC. Okay. This is definitions. You just memorize them like this. Cosine of an angle, the cosine of an angle, it's the adjacent side divided by the hypotenuse. So cosine of angle theta, this is angle theta, it is the adjacent side, which is this side, divided by the same hypotenuse. The hypotenuse is the same. So cosine of angle theta will be the adjacent AC divided by BC. Okay. Tangent of an angle, the tangent of an angle, you just memorize it. It is the sine of the angle divided by the cosine of the angle. If we put now opposite over hypotenuse over adjacent over hypotenuse, we will get that the tangent is the opposite divided by the adjacent. So the tangent of angle theta is opposite, which is AB divided by AC. So the tangent is AB divided by AC. Let's look now at angle alpha. So let's apply the same rules, but for angle alpha. The sine of angle alpha is opposite divided by the hypotenuse. What is the opposite of angle alpha? It's AC. The hypotenuse, BC. So it is AC divided by BC. The cosine, it's adjacent. It is BC. Sorry, the adjacent, it's AB divided by the hypotenuse. So it is AB divided by BC. And the tangent of angle theta, it's opposite over the adjacent, so it is AC divided by AB. Okay, these you just memorize them. Let's apply them in a few examples. For the right triangle with sides as shown in the figure below, find side X and the angle theta. Okay. The first thing I noticed that I have the two sides and I need a third side. To do this, you use Pythagoras theorem. So Pythagoras theorem, the hypotenuse square, it's equal side 1 square plus side 2 square. Hypotenuse is 6.2. It's equal to one side is X and the other side is a 3.5. So X square will be 6.2 square minus 3.5 square. X squared is 26.19, X equal 5.1. So now I have this X equal 5.1. Now we need to calculate angle theta. We have all the sides. I can use sine theta is 3.5 over 6.2 or cosine theta 5.1 over 6.2. So I can use whatever I want. I can use sine. Let's change the color. Sine theta is equal opposite, which is a 3.5 over hypotenuse 6.2, or I can use cosine theta equal adjacent, which is 5.1 over 6.2, or I use tan theta equal opposite over adjacent, so 3.5 over X, opposite over adjacent. Okay, and in any case, let's say case 1 implies theta equal sine inverse of this number sine inverse. It's difficult to put it here, but I put it here. So let's assume that here what I use this one. I use cosine theta. So cosine theta, it's x over 6.2. So it's 5.1 over 6.2. Cosine theta equals 0.82. To get theta on the calculator, on the scientific calculator, you put cosine inverse 0.822. Okay, so this is called cosine inverse. You can find it on your calculator. You put shift cosine. So cosine inverse, to get this cosine inverse, it is shift cosine. Okay, so shift cosine 0.822 will give you this answer. Okay. If you want to do it on sine theta, it is the same. First, you have to calculate what is 3.5 divided by 6.2. 3.5 divided by 6.2. This will be 0.56. Okay, implies theta equal shift sine. Space. Let's do it here. Let's do it here. Okay, you can try it on your own. It's easy. You just put sine theta equal 3.5 divided by 6.2. 3.5 divided by 6.2 is equal to 0.56. Then you put shift sine 0.56 and you will get the same answer. Okay, so this is here 0.56. So to get theta on the calculator, you put shift sine 0.56 and it will give you the same answer, 34.65. Okay, or you do it on the 10, you should get the same answer. Next problem. For the right triangle with the side and angle as shown in the adjacent figure, find the missing sides x and y where theta equal 36. So this is theta here. We know it, it's 36. Okay. So we need x and we need y. We notice that x is the adjacent of 36 and we have the hypotenuse. So I need the adjacent. I need the cosine, or I need the angle. So you say cosine theta, it's equal to the adjacent, which is x, over the hypotenuse, which is 7.1. So x equal 7.1 times cosine 36. On the calculator, this will be 5.74. To get y is the opposite of theta. Y is the opposite of theta. I have theta, I have the hypotenuse, so I use sine theta equal y over 7.1. So y equals 7.1 sine 36, and this will be 4.17. Okay, let's move on. From a hot air balloon, the angle between a radio antenna straight below and the base of the library downtown is 57. If the distance between the radio and the library is 1.3, how high is the balloon? So don't worry about all the English here. Just look at the picture. You have the angle is 57. You have this side 1.3, and you need to get this side. Okay, so what do I have? I have the angle. What do I have also? I have the opposite of the angle, and the unknown is, so I have the angle, I have the opposite, and I need the adjacent. So which one of the three equations can help me get that? It's the tangent. Tangent is opposite over adjacent. Theta is 57, so tangent 57 equal. Opposite is 1.3 over, let's call this h. So cross multiplication, h times tan 57 equal 1.3, h equal 1.3 divided by tan 57, 1.3, tan 57 on the calculator, you calculate it, 1.3 divided by that, you get H. Okay, let's do a last one. A 17-meter ladder leaning against a wall has its foot, blah, 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 blah. So everything is on the drawing. There is, this side is 17, this side is 8, and he's asking for this side. So I have two sides and I need the third side. What do I use? I use Pythagoras theorem. Hypotenuse square equals side 1 squared plus side 2 squared. The hypotenuse is the side facing the 90 degrees. Okay, so that's 17 squared equal 8 squared plus h squared. H squared is 17 squared minus 8 squared. You solve it, you get h equal 15 meters. Okay, so in order to do all these exercises, you have to memorize Pythagoras theorem, the sine of an angle opposite over hypotenuse, the cosine of an angle, and the tangent of an angle. Okay, so you memorize these, and then you can solve any exercise with trigonometry. This is the end of today's lecture.